All right, I thought I would do some of the problems from each section here. I imagine it'll take several videos to get through this. This is 8.8 on page 386 in the Algebra 1 book. I wanted to start with some that I thought might be a little confusing for you. Look at number 3, q of x equal 2 minus 1/3 x. Okay. Now the q of x is just function notation for maybe they're graphing something that starts with q on the y-axis. So remember what you can just do if that bothers you is just put y here. And you could have the equation y equal 2 minus 1/3 x. But there's another thing here that's a little strange. Not strange, just a little confusing. If they wanted to put this in y equal mx plus b form, they haven't written it in the right order. And for a lot of people, that confuses them. So what you can do is, remember, write the x term first, and you're going to take the sign with it, so that would be negative 1/3 x. Now you're going to, this is a positive 2, that's why there's not a plus in front of it. If it had been a negative 2, you probably would have known to put minus 2. But since there's no sign in front of it, we are adding these terms together, so you could put plus 2. Now this is a little easier to graph or to think about. I'm going to just put a few little marks on my graph here. And if you remember, now the b term, which it's the plain number term in the equation, and now that I've written it in y equal mx plus b form in the correct order, I see that it's 2. So let me graph that. 2 would be here. And then if I'm looking for my slope, it is negative 1/3. Well, negative 1/3, remember that's my rise over my run. That's another way to think of slope. And when we're going to count it off on a graph, it's a handy way. So I'm going to start at that green point. I'm going to go down 1, and then I'm going to go right 3. And there's my new point. It would actually be, if you're looking on the graph, it would be at 3, 1. So I can just connect those two, which is hard to do on the iPad, but you get the idea. If I connect those two, I'm done. Now 5 is also one that probably is going to confuse you just because it looks a little different than you're used to seeing things. It's r of x is equal to negative 7. And you may think, well, what am I supposed to do with that? Well, remember, this r of x is just function notation. And maybe the y-axis, they're going to graph something like, who knows, a number of raccoons or something. I don't know what r could be. But we're going to cross it out, and I'm going to put y so that I can think about it easier. This is y equal negative 7. And remember, when you have y equal a number, that's a horizontal line through that number. So let's see, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7 would be about down here. I'd have to extend my axis on a little bit. And a horizontal line goes like this, and we're done with that one. All right, number 7, f of x equal x squared minus 5. And they ask us to find the coordinates of the vertex and then give the equation of the axis of symmetry and the least value of the function. There's a lot going on there. So they want the vertex. And if you remember, when we find our vertex, we label our equation and we take off the b and divide by 2a. It's negative b over 2a. And then I have to plug that into the function to get the y value that goes with it. So we could write it like this, which is what they're doing here. This just means the y value that goes with it. So whatever I get for the x value, I'll plug it into the function and get the y value that goes with it. So I'm going to have to do that. If you remember, the axis of symmetry goes through the vertex. It's a vertical line through the vertex. Since it's a vertical line, it's going to be x equal whatever the x value of the vertex is. Well, if you look up there, the x value of the vertex is negative b over 2a. Now, where are these b's and these a's coming from, in case you've forgotten? Let's go look at the equation for a minute. Remember, I can cross f of x out and put y in its place if I want to. And then, if I think about how to label this, I'm going to put the minus 5 down here, because when we label this, remember, you say the coefficient of the x squared term is your a. In this case, it's going to be 1. Let me write it over here. The coefficient of your x term, that was the x squared term, was 1. Now bx, b is the coefficient of your x term, and c is your constant. Well, I can see that my constant here, my plain number that does not have an x with it, is negative 5. But what about B? It's missing. Well, if it's missing, it's just 0, because I could say that's plus 0x, and 0 times x would be 0. That's why they didn't write that down. All right, so we have to label our equation. We have to notice if something's missing. If it's missing, we fill in with a 0, or if it's missing out front, like x squared, that's 1x squared. So we didn't put 0 for the a value here since it's 1. All right, the least value is the minimum of the function. Usually the minimum is the vertex. It's a minimum or the maximum, dependent if the parabola looks like this when we graph it. The vertex is always a low term, so it's going to be our lowest term. If our function looks like this, the vertex would be the maximum, the highest value on the graph. So that's all. This looks like a lot of work, but it's going to come out to be not so much when we realize that we're talking about a lot of the same values here. All right, so let's get to it. Negative b over 2a. Let me pick another color to do the work in. Well, b is 0. If I'm looking right here, I'm going to find my vertex value. B is 0, so it doesn't really matter what goes on the bottom. It's going to be 2 times 1. But 0 divided by 2 is 0. So my vertex value is going to be 0. Let me just write it here. And now to find the y value that goes with it, I have to go plug it into the equation. So let me come down here. The equation was y equal x squared minus 5. Instead of putting the x there, I'm going to plug in the 0 that I found. Well, that would be 0 squared is 0 minus 5, which would be negative 5. So my vertex is 0, negative 5. They didn't ask us to graph it, so we won't here. We're going to have plenty of graphing opportunity here in a minute. Now, this negative b over 2a, I already did the work once. It was 0, so I don't have to do it again. Here's my vertex. My axis of symmetry goes through the x-coordinate of the vertex, so I could plug b and 2a in again. But it's just going to be x equals 0 if I just realize that these values are the same, okay? The vertical line goes through the x value of the vertex. Now, the minimum value then is our vertex. If we were to graph this, it would be, I can actually graph this really quickly because this is an easy one to graph if you just know a little bit about some of this stuff. My vertex is at 0, negative 5, so it's right here where I'm drawing the dot. And then it's going to open up like this. We're going to talk about parent functions. The parent function for a parabola, the simplest one you can graph, is y equal x squared. And all they've done in this problem is taken the y equal x squared and they scooted it down 5. That number on the end literally just scoots the graph down 5 units. So it would have the parent function would have been up here. I'll draw a green parent function in. And all we did was scoot it down 5. That's what the minus 5 on the end of the equation does. All right, one last one probably for this video, and we'll be out of time. Let's look at 15 because it looks fun. h of x equal negative x squared minus 8x minus 15. Okay, first of all, let's just call that y so we're not so freaked out by it. Notice every term has a negative on it, so let's just factor it out. If you factor it out, that's going to be x squared plus 8x plus 15. Now, here, let me label this first. I guess I should say this is ax squared plus bx plus c. The reason I was factoring it out was that actually, I didn't have to do it here. If I were going to graph this, I would have wanted to have done that. So let me just cross this out. I was kind of thinking about graphing it, but we won't since they didn't ask us to here, and we'll save the graphing for another one. A is negative 1. B, oops, come on, show up negative. B is negative 8, and C is negative 15. So if I want to find my vertex, remember it's a point, and it has an x value and it has a y value. And the x value of the vertex is also my axis of symmetry. And we find it by saying negative b over 2a. So if I want to find that, x equal negative b over 2a, that's going to be negative 8 over 2 times negative 1. Well, a negative 8 is a positive 8. 2 times negative 1 is negative 2. 8 divided by negative 2 is negative 4. So my axis of symmetry is x is negative 4, and my x-coordinate of my vertex is x is negative 4. It's a 2-for-1 equation. It doesn't get better than that in math. All right, so now we got to go find the y value of the vertex because it's missing, and I know x is negative 4. So what I'm going to do is plug in negative 4. I've got to square it. Minus 8 times negative 4 minus 15. Well, negative 4 squared, doing PEMDAS, I'm going to square the negative 4 first and get 16, but it's got a negative out front. Now, negative 8 times negative 4 is a positive 32 for the next term, and then minus 15. It looks horrible, but this actually just ends up being 1. Negative 16 plus 32 is 16, and 16 minus 15 is a positive 1. So my vertex is negative 4, 1. My axis of symmetry is x equal negative 4. It's always a vertical line. And then my maximum point here, here's one thing I know about this equation, and we need to talk about it. You see this negative up front? What it does to a parabola, a negative out front of a parabola, and really a negative out in front of your leading term, it always reflects the graph over the x-axis. So if it's going to reflect the graph over the x-axis, that means that it's going to open downwards. And I can go graph it, and I'll know it's going to open downwards. So it's going to open downwards. My vertex is going to be here. Do you see how that's going to be the highest point on the graph? I could put a graph in here like this or something, but basically my highest value on my graph is my maximum value. My maximum value then is going to be the point negative 4, 1. Usually when they say the maximum, they're talking about the y value. So the maximum y value would be the 1 there. Let me circle it. Your answer actually, the maximum value is 1. It's the y coordinate. It's the highest the graph's going to get.